Hey y'all, my name's Danny Leybzon. I am not based out of Vancouver. I actually am down in Taos, New Mexico right now and generally live along the west coast of the United States. But I had a really good time back in 2019 speaking about automated machine learning at this meetup. So I reached out to the organizers and asked if I could give another presentation this time about monitoring machine learning models. I work at a company called Imply, which basically took the open source product Apache Druid and created a managed version of it. If you're not familiar, Apache Druid provides super fast analytics on streaming data. It's really useful for a whole range of different things, IoT, application performance monitoring, which is what's most relevant to today's talk. But it also, can replace Postgres and Redshift and a whole range of other databases, data warehouses, and data products. But I'm actually going to try to minimize the amount that I talk about Imply because I want to talk about the cool, interesting, difficult topic at hand, which is monitoring machine learning models. So with that, I'm going to launch into my presentation. Actually, sorry, before I do that, like Matt mentioned, I really want to emphasize, please, if you guys have a question at any point during my presentation, don't hesitate to just blare it out. If you feel a little bit awkward or shy, feel free to just post it in the chat. And Matt, if you don't mind monitoring the chat for me.
Yeah, I just opened the chat.
Perfect. So the topics that I'm going to talk about are going to build on each other continuously. So if there's something early on that you don't understand, it's really important that we try to get it cleared up and clarified early on. And I promise you, if there's something that's not clear, you're not the only one that it's not clear for. Other people will appreciate the opportunity to dive into something. I take all of this stuff kind of for granted because I've been studying it and talking about it for so long. So I often overlook kind of like simple baseline things. And I also know that I have a tendency to speak really quickly, especially when I get excited. So to compensate for that, please just cut me off at any time. So we're going to be talking about monitoring machine learning models, which I've cheekily referred to as the final frontier. I've broken down the talk into three major components. First, I'm going to talk about the what, right? Like defining terminology, understanding what is machine learning monitoring rather. Then I'm going to be talking about the why, right? I want to make sure that you guys are interested in this and really understand the importance, the value of this in order to really get at the how, which is the final part of today's presentation. I have a theoretical component where I compare different options in the market and talk about what do we look for in a monitoring tool. I also used to have a practical component which was basically a few Python notebooks and the Imply product. I've been having some technical issues on my laptop, so unfortunately we're stuck in just the deck today. But hopefully that'll still be valuable for y'all. So without any further ado, let's dive into it. What does it mean to monitor a machine learning model? Well, in order to understand monitoring, you really need to understand productionization, right? The general process of taking a machine learning model out of what we call the data scientist's sandbox, outside of the development environment, outside of the IDE, and actually deploying it so that it's providing value for the organization. And a lot of the conversations that we have around productionizing and deploying machine learning models were actually triggered by one paper from Google called Hidden Technical Debt in Machine Learning Systems, which probably triggered the career of the majority of machine learning engineers that are currently employed. Because in this paper, what Google demonstrated, what they talked about and showed, was that it's actually not enough to just hire data scientists. You need to hire programmers that can deploy the machine learning models that those data scientists develop, right? As you can see from the visualization I pulled out of the paper, ML code, this little black box, actually is a very small component of the overall serving infrastructure that it takes to deploy a model, right? We've got configuration, data collection, all of these different things. And all the way out here on the right, we've got monitoring. And that's what I really wanted to dive into and talk about today. Historically, I've given a talk about machine learning models in production, about the process of deploying them, and I've broken down the machine learning workflow. And I think the concept of breaking down the process of developing and deploying a model is a really useful thing to do. At the time, I just broke it down into three stages: exploring and preparing data, building and validating a model, and then deploying and monitoring the model. And I mostly have focused on the build and validate and on the deploy without really talking about the monitoring. But actually, I've come to the realization that, just like every other model of the universe, this model of the universe is wrong, right? It was useful, but it's not necessarily true. And the reason for that is because it is a gross oversimplification. It is incredibly reductionistic. And in order to really understand the value of monitoring, I pulled out and decided to focus on just the second two components and stole somebody else's visualization that is both much more in-depth and much neater than mine. So I took this from a blog post called CD for ML, which comes from Martin Fowler's website. If you're not familiar with Martin Fowler, he's a really big deal in the world of software architecture. And this particular piece of work on his website is really incredible at diving into how do we think about machine learning in the context of the greater application that we're building? How do we think about machine learning code in the context of the overall platform or the general code that we're writing? So the author of the paper broke it down into 6 steps instead of my 3, and actually broke down the steps into 3 components that they would interact with: code, a model, and data. So let's walk through this whole flow. So we start off with doing model building, right? So we've already done all of our data preparation and exploration. We're just here starting to build a model. So building a model requires coming up with training code, right? Usually in Python or in R, right? We use scikit-learn or whatever library. Maybe we even build our own neural network, whatever it might be. We need training code. We also need training data, right? We need to bring in data that we use to develop, to teach the model, because this is machine learning after all. And then the output of training code and training data is a series of candidate models, right? Because we're not going to be satisfied with just a single model. We want to compare the performance of different models against each other using a number of different metrics. And that's really what comes in key as for the model evaluation and experimentation, right? Because what we do when we're evaluating a model is we take a different set of data, not our training data, but test data, right, to prevent overfitting. We take test data, which probably resembles the training data, probably is pulled from a similar process, and we apply it to the model. And in response, the model will generate a series of metrics. Now, metrics is a very broad term, right? It could encompass a lot of things. In general, when evaluating a model, people will primarily look at some kind of accuracy metric, right? Maybe in like a regression, they'd look at the R squared. In a classification, if they're being very naive, maybe they look at the accuracy. More likely these days, they're going to look at something cool like F1 or harmonic mean or area under the ROC. So there's a number of different metrics that you can use to evaluate a model. But ultimately, the end result of this process should be choosing a single model that you're then going to productionize. And productionizing a model basically means taking this Python code that we wrote or this R code that we wrote and then putting it into something that can integrate with our product. So maybe we're going to rewrite the model so that it's accessible in C++ because that's what the rest of our application is written in, or maybe in Java. Maybe we're going to deploy it with a tool like SageMaker, whatever it might be. We need to take our model from some one code artifact into a code artifact that can actually be deployed. Now, from there, we need to actually test out our productionized model. This is different than the evaluation stage because now that the model is deployed, it's been modified, and we want to make sure that it still functions as part of the larger application. Now, that model, once it's been deployed, can be integrated with application code. And the end result is that we've got this code, which represents a model in production. And now we've got production data coming in, right? Which is different than both test data and training data in the fact that it's being generated in the real world. And then the results of predictions made on production data is then used to serve inferences to the end user. And if this sounds all super abstract, I understand, and don't worry, let's talk about a specific example. So let's say I'm an engineer at Netflix, or a data scientist or machine learning engineer at Netflix, and I'm working on a recommendation algorithm. How would I do this? I would start by building a model based on some set of training data that I have. I would build a couple of different recommendation systems, maybe based on different algorithms or maybe using different hyperparameters. Then I would productionize and deploy whatever model I'd selected as being the best performant. And now every time somebody logs into the Netflix website, the data that they previously had generated based on their viewing habits is going to be sent to the model that I've deployed. And then that model is going to make recommendations about the movies that I'm going to watch, right? So all of this happens whenever I load up a Netflix page. And it's really important that it happens quickly. And I'll get back to the importance of it happening quickly a little bit later. So at the end of stage of this, we've deployed our model, but just like any other piece of code, you don't just hit submit and then walk away, right? Hopefully not, because you need to be able to track and make sure that your application is still performing. Right. So, and that's where monitoring and observability comes in. Monitoring and observability is a key component of the classic software development lifecycle. And it's really important that we integrate it with the machine learning development lifecycle as well. Now, I think one really nice touch that this blog post actually puts on is this arrow circling all the way back to model building. Because I think fundamentally at the end of the day, monitoring and observability are only useful in that they might trigger a new series of model building. Right. If I start to see performance in my model, degradation in my performance of my model, or if I start to see that that I could potentially have some kind of improvement, this should trigger this whole sequence all over again. So monitoring and observability is really only useful if it could potentially trigger a new cycle through this whole process.
Hey, Danny, just a quick question here. Will you be putting up these slides somewhere? Is there any way that we can grab them? I'm just curious about the link itself.
Yeah, absolutely. I'm super happy to share these slides. Maybe Matt, I'll email you the deck and my LinkedIn profile.
Okay.
As kind of the two takeaways that people can have. Absolutely.
Awesome. Thank you.
Yeah, I'd super recommend to any like machine learning engineer or anybody who's like interested in figuring out how do we integrate ML with our existing application. This was a really, really foundational blog post that I found to be super useful. Are there any other questions about this life cycle? What it looks like to build and then deploy and then monitor a model?
So this is something that I have struggled with before. Code, it makes sense to use version control with data, like there's usually some sort of marker there, but doing any kind of version control on models themselves, do you have any experience with that, and what have you used in the past?
Yeah, so I mean, I personally have only ever used GitHub for this because there are, it's not as apparent, but there are differences in the trained parameters of models. So you can still compare them against each other and do version control in that sense. I think there's a lot of like fancy new machine learning platforms that like H2O, Data Robot. I don't know if H2O, I'm pretty positive will have some kind of machine learning model versioning system. But yeah, I personally have only ever used GitHub. And that's one of the really interesting things about machine learning compared to classical engineering and software development, right? Because we have historically struggled to take the best practices that were developed in software engineering. And part of that is just that a lot of people that do machine learning don't have backgrounds in software engineering. Like I personally have a background in statistics. A lot of people have backgrounds in social sciences. But part of it also is that like machine learning models are both fundamentally the same and fundamentally different than traditional applications and traditional code, right? There's like a lot more variability in them. That it might be a little bit more obfuscated, without interpretability. It might be really challenging to understand why a model is doing something versus hopefully we understand why our code is doing something. So that there's definitely some peculiarities that make it challenging to apply traditional software engineering principles to machine learning. And that's why it's so important that we have conversations like this, where we try to bridge that gap in order to create best practices for ML. Any other questions? Cool. Okay, so let's get back to grounded reality and away from the world of head in the sky abstractions. So what does it mean to monitor an ML model? This is the strictest, clearest definition I could come up with. Creating and tracking metrics about the performance of a machine learning model in production. And now metrics is a term that I think needs to be defined a little bit better. And I've chosen to break down metrics into three components. Some people choose to skip the last category of metrics. I'll talk about why I think it's still important to have it, but let's look through each one of them individually. So the first type of metric we might have is metrics about data being fed into the model, which I term data monitoring, right? So this means looking at data coming in and making sure that it's basically similar to the data that we use to train our model. And I'll talk about why it's important that it's basically the same a little bit later, but fundamentally understand that data monitoring is about monitoring the incoming data. And there's a couple of different things that we can use to look at this. We can look at like standard deviations. We can look at the means of incoming data. For categorical data, we can see if there's any new categories being added, which might interfere with the model's ability to make predictions. Basically, we want to make sure that data coming in is similar to the data that had previously been trained on. Now, the second set of metrics that we can collect and monitor about a model is prediction monitoring metrics. So these are actually looking at the results of the model, the inferences that the model has made. And similarly, we can collect a number of different metrics about this. We can look at the confidence. If we've got like a sharp drop off in the confidence of the model, this probably indicates that there's something going on that's making the model perform worse. If we see that there's like a huge class imbalance that didn't previously exist in the predictions, that's similarly an indication that maybe there's something that's changed. Finally, there's metrics about the application performance when making predictions, which I term system monitoring. So system monitoring, as I mentioned before, is oftentimes overlooked because it's really much more of a traditional like SRE or DevOps style thing to think about rather than things that a data scientist would think about. But actually, to get value out of our applications, I think it's really important to continue to monitor the system that's making it, monitor the CPU being consumed, the RAM being consumed, the amount of SSD left, and especially monitor how long it takes for your model to make the results. These SLAs, the service level agreements that the data science or machine learning team has with the general platform team, can be super impactful and can actually negatively impact the performance of an overall application. So imagine again the situation that I'm a Netflix engineer and I'm twiddling around with my model and I've managed to get like crazy accuracy improvement, but it was by dumping another like, let's say 10 or let's be ridiculous, let's say like 100 layers to a neural network. Well, okay, cool. Like my model performs 0.1% better, but if it takes like 3 times as long, if it takes 5 seconds to generate the predictions, then all of a sudden my Netflix page is going to take an extra 5 seconds to load, right? And as a modern ADHD user, I might click away from Netflix if I have to wait for it to load. And that's the last thing that Netflix wants, right? Google actually has released studies about the average amount of time that people are willing to stay on a page and wait for it to load. And it comes out to a matter of seconds. So if your machine learning model inferences are taking too long, you're slowing down the overall performance of the application and therefore driving people away from it, which can negatively impact your business. So these are the 3 categories of metrics that we might collect and monitor about a machine learning model in production. Any questions about what before we get into why?
Danny, I have a question.
Yeah.
And I'm sorry, I'm quite new to this field of data science. So I just want to ask you, does it make sense at some point during the monitoring to go for a different model from the one initially built?
Yeah. I mean, absolutely, right? That's the whole point of this arrow going back, right? Like, what's the point of monitoring a model if you're not willing to make changes? Let's say that I started off by having like a really simple model, like linear regression, because I knew that there were linear correlations and linear relationships between the input and output variables. But over time, right, data shifts, real world processes shift, and maybe now there's nonlinear relationships between the input and output variables, right? In that situation, it makes sense to try to switch to a different type of model, maybe a more complex model, maybe one that can capture these nonlinear relationships better. Another situation where you might want to like deploy and then iterate is in the situation that you're trying to do agile development, in the world of startups, where great is the enemy of good, or perfect is the enemy of done, right? Because at some point, it matters more that you deploy something, right? Even like a 25% lift isn't worth it if it takes an extra year to get to, because sometimes you just need to get something out right away. So yeah, I would say it's definitely sometimes worthwhile to change the algorithm even that you're looking at for your model, not just retraining it on data or something like that.
Right.
Does that answer your question? Yeah.
Yes, thank you.
I had a question as well. Hi, Elena here.
Yeah.
Would you mind going back to the previous slide?
Absolutely. Oh, sorry, this one or
that one? Yes.
Yeah. Uh-huh.
So at some point at our reading group, we read this paper. There was, I think it was from booking.com, and it was about how there was no correlation between sort of the kinds of metrics that the data scientists were using to evaluate their models, like, the accuracy and the area under the curve and all those kinds of things, and the KPIs of the business resulting from the use of those models. And so I'm wondering, in which of these category would you put those more closer to business metrics kind of deal? Or is that a fourth category that needs to be added?
Yeah, so that's a really great question, Elena. So I think one of the interesting things about data science is that it like really fundamentally should be and is a science, right? And I don't just mean this in the sense that we apply the scientific method, but in the sense that data scientists aren't strictly engineers, and that oftentimes the business value that they create isn't like immediately seeable for a business. So you're totally right that these three metrics, these three categories of metrics, don't necessarily perfectly capture the KPIs or the MBOs of a particular business. But instead, what they do, hopefully, if the data scientists did their job well of scoping out the model, hopefully they point towards some KPI. For instance, I'm just going to keep coming back to Netflix because it's the one that's top of mind, because you guys know what I'm going to do after today's presentation. So imagine Netflix, right? The KPI for the machine learning model in that situation is they're trying to get people to maximize the number of times they renew. Like they want people to stay as members, which oftentimes I think is correlated to the amount of time that people spend watching stuff on Netflix. If I never watch Netflix because I think it doesn't have any good shows, then I'm not going to renew my subscription, versus if I'm watching something every night because Netflix gave me good recommendations, then that's going to drive a lot more revenue for the company. So in that sense, there's like one extra step between the outcomes that data scientists look for and the actual KPIs of the business. And I think you're totally right in identifying that there's often like a mismatch because scientists don't necessarily think about business value. But I don't think that that's an inherent difference. And most importantly, I think it can be challenging to track KPI direct relationship to a model. What I mean by that is like, when I deploy a model, it's very easy for me to monitor data going into it, the predictions that it's making, and the system that's running the model. And I can separately also monitor, how many people are continuing to be on Netflix. But making that causative argument between my model is working well and people are staying on the platform, I think it's kind of challenging. It's a big logical leap to try to make there. So I think that in a sense, it's useful for data scientists to think about the end KPI, because ultimately we should be driving business value for the companies that we work for. But in the near term, like using these three categories of metrics is the best that a data scientist can do. Does that kind of make sense? I know that was a lot of words all at once.
Yeah. Essentially, it's not in any of those three bullets, but if we've at least handled those three, we're still some good ways into doing a good job.
Correct. Yeah. Like as long as you've scoped the project correctly so that the model is actually creating business value, like tracking the business value is super important, but it's not really monitoring the machine learning model in the sense that like monitoring an application is different than tracking KPIs that the application produces.
Thank you.
Yeah. Thanks for asking the question. That was really insightful, Elena. Any other questions about what? Cool. Okay, then let's talk about why. I think this is probably intuitive for a lot of you guys, but I think it can be useful to take implicit things and make them explicit. And this gave me another opportunity to break things down into three categories, which if you guys haven't noticed is a thing that I do pretty regularly. So why should I monitor a machine learning model? I think there are three primary categories of reasons that people provide. One is a difference between sandbox and production data. Two is shifts in processes generating the data. And I'll talk about two different versions of that. And three is externalities affecting the system. So let's dive into each one of these individually. So the first is differences between sandbox and production data. And actually, if you're doing your job well, you should realize this before it gets into the monitoring stage. The reason for this is that there might be a mismatch between the data that you use to train and test your model versus the data that's actually being sent to it. Oftentimes this happens because data scientists are too gung-ho about feature enrichment, about cleaning up their data. They make their data kind of perfect in order to try to maximize and squeeze out every last percentage of accuracy from it, right? But in reality, the difference between Sandbox and production data is hugely important, because if the Sandbox data isn't representative of production data, then you're going to see a huge reduction in degradation in your performance compared to the performance that you originally got when you trained your model in the Sandbox. So I think this is pretty intuitive for all of us, right? Sometimes businesses will give you a certain set of training data, and then in the real world, the data is different. And this is specifically capturing that idea when the data is stable, when this error or this change, this mismatch occurs before the model gets deployed. Now, there's also a very related category of why should you monitor your model, which is shifts in the processes that generate the data, right? So it might be that right off the bat, the Sandbox and production data matched each other, but over time, because things in the real world are dynamic, there might be changes to the things that are going on in the real world that generate the data. And the first category of this is independent changes in the real world. And we actually just had, I guess it's been a year now. That's crazy to think about. A year ago, there was a huge change in the real world that affected probably most machine learning models that have been deployed, right? Every machine learning model got affected, and every human process and then every machine learning model got affected by COVID, right? People started radically changing their shopping behavior, their online browsing behavior, their exercise regimes. Literally everything that you can think about has been affected by COVID, right? And these independent changes in the real world means that data or models that you originally trained on data that represented a pre-COVID world might not be representative of COVID world data. We actually saw a lot about this. In the first couple of months after COVID, there were some really good articles put out that really emphasized the importance of interpretability of machine learning systems, and that this was a huge use case for interpretability, right? Because if your model all of a sudden stops performing as well, it's important to understand why. But in addition to independent changes, there's also model affected changes that can happen in the real world. This is something that comes up a lot when the model is actually trained on behavior that the model itself is going to affect. If we think about Netflix for the millionth time, the movies that I choose to watch are affected by the movies that are recommended to me by Netflix. So if Netflix doesn't add any noise to their recommendation algorithm, I might start going down a rabbit hole of one particular movie that I liked some amount, even though maybe there's a different genre that I would also like if they had just given me the opportunity to watch it earlier on. So there's model affected changes that happen to the processes that generate data in the real world. Stepping away for once from Netflix and thinking about Twitter, similarly, the tweets or the whatever posts or content that social media chooses to feed to us affects the content that we interact with, thereby changing the data coming into the machine learning model, which is why it's important for these social media giants to constantly be monitoring their models in production. But the last thing that might affect that might make it crucial to monitor a machine learning model is externalities affecting the system on which the model runs. And this really comes back to our system monitoring component, right? So there might be a spike in network traffic that ends up slowing down our model. There might be a spike in other resource allocation on the machine that our model is deployed on. Or basically, there might be some kind of externality, something not key to the machine learning process itself that is affecting whether the system, whether the deployed model is actually continuing to perform, specifically in terms of system metrics. So that's a brief overview of the why. Hopefully this was pretty compelling, and it's getting you guys to now ask the question of like, okay, I've deployed my model and I'm sold that I need to monitor it. How do I monitor it? But before we get into the how, do y'all have any questions about the why? Cool. Okay, then let's talk about how. I think fundamentally monitoring systems have three primary components. The absolutely essential one is processing and storage, right? These metrics, which underlie what a monitoring system does, need to be stored somewhere, and then they need to be processed in order to be able to be accessed, right? But beyond processing and storage, there's also visualization and alerting, which, while not absolutely fundamental, I would say are kind of table stakes at this point for any kind of monitoring system, but for machine learning monitoring systems as well. And I pulled this visualization from another great blog post that I really recommend for anybody who's really interested in getting an even deeper dive into monitoring ML systems. This blog post is super in depth. He covers a lot of the same topics that I do, and just super highly recommend it. So in addition to processing and storage, we also want to be able to visualize changes in the data. They visualize changes in these metrics in order to understand trends over time and in order to understand the magnitude of changes that have occurred, right? Visualizations are really, really powerful because human beings are much better at understanding visual information display than they are tabular or numeric information, right? These visualizations are really powerful because, as I mentioned earlier, they let you look at trends over time and thereby let you estimate the magnitude of changes that have occurred, which is super important when we look at something like model drift, when we look at things like mix shift, or any of the other types of events that might be affecting how our model performs. Now, visualization is great for human in the loop monitoring, right? If I am constantly, or every morning I wake up and I check my dashboard to see how our model is performing, that's great for the model, but not so great for Danny, the human being who has other stuff to do with his day, right? Which is why alerting is another key component of monitoring systems, right? Alerting is really useful because it allows you to take machine intelligence, and I'm using this term very, very broadly. You can set up alerts on just, some baseline number, like if the amount of time it takes for my model to produce an inference goes above 2 seconds, let me know. Or you can go all the way to like an advanced machine learning based anomaly detection system where you say, wow, it's really weird that I made this prediction for this one particular person. Please notify me that I did this, and then I can go in and kind of investigate using some kind of interpretable ML system. So alerting is really powerful because it allows you to take the human out of the loop for some period of time, but then bring the human back into the loop for actually investigating the change or the cause of the alert. So these three components of monitoring system are really key, not just for monitoring machine learning models, but really for monitoring any kind of system, any kind of code deployed out there. So with this in mind, I broke down the tools that exist out there into application-specific tools, which focus specifically on machine learning models in production, and on general purpose tools, which focus on general application performance monitoring. So let's talk about application-specific tools. The first one I would say is the one that, I take it back. Okay, so there are application-specific tools made by cloud providers like AWS, like GCP, like Azure, or other machine learning deployment providers that allow you to monitor an application or a machine learning model that you deploy within their platform. So far, I've been pretty thoroughly unimpressed with the monitoring capabilities that these guys have. A lot of the time, it's literally just collecting metrics. There's not any kind of visualization or alerting capabilities built in. Sometimes there's like an integration with an external alerting or visualization system. But overall, I would say that these seem to be ways for Amazon or Google or Microsoft to say like, hey, look, we have monitoring as part of this, and to just kind of check boxes on people's PRs. So where I think the most interesting work is being done here is, of course, in the startup space, right? Where there's a lot of really cool tools like Superwise, like Fiddler Labs, which develop specific tools for monitoring machine learning models after they've been deployed. And what's really exciting about these application-specific tools from small startups is that they tend to integrate with interpretability systems. And I think that monitoring and interpretability are two really interconnected concepts that don't really get enough attention together. If you're not familiar, machine learning interpretability is basically the problem of trying to figure out, why did my machine learning model make this particular prediction, or understanding how does my machine learning model make predictions. And if you're curious to learn more about interpretability, I hope to create another presentation diving into the current approaches to explainability and interpretability. But for now, just understand that startups are doing some really cool work in integrating observability monitoring with interpretability, interpretability, explainability. And these startups tend to provide more application-specific tools that can be super useful for companies that are looking specifically to monitor machine learning models. Now, the third category I put in here, not because I think it has a strong offering, but because I think I would love for it to have a strong offering. Unfortunately, there just isn't that much attention in the open source to monitoring machine learning models in production. There's like a couple of attempts to do this within Kubernetes, which is a deployment provider. But overall, there's just not a lot of open source projects that seem to focus on trying to solve this problem. I think part of that is that the space is very new, the techniques are very specialized, and that the larger companies just haven't, and like these days, a lot of open source projects come from larger companies. A lot of larger companies haven't themselves coalesced around a series of best practices for monitoring, so they don't feel confident in creating an open source project to give out to the community. So overall, the open source project, not a great place to look for application-specific tools for monitoring machine learning models, but I think it's something that we could see a big development in the future. So I've talked about application-specific tools, right, which are made specifically for monitoring machine learning models. But as I've tried to talk about throughout today's presentation, machine learning models can be abstracted and be thought about as being very similar to a lot of other types of applications and code, which means that you can do the same techniques of application performance monitoring for machine learning models as you can for any other application. So for general purpose tools, I've broken it down into two categories: commercial vendors and open source projects. Now, commercial vendors allow you to monitor and analyze data about how your model is performing. And I happen to work for one of them, right? Which is why I focus on this category. So I work for a company called Imply, which, as I mentioned at the beginning of the talk, took the open source project Apache Druid and built a managed service around it that includes alerting, it includes a visualization layer. Generally, it provides the ability for users to use Apache Druid to do application performance monitoring. They can use it as a data warehouse. They can use it as a BI tool. They can use it for a number of different purposes. So I'm mostly going to talk about Imply in terms of commercial vendors, just because I'm in direct competition with everybody else. But I also want to give a shout out to open source projects in the space. I think that they are not quite as good as the closed source solutions. They require a lot of work to stand up, but Grafana and the Elk stack are still really good at monitoring logs and allowing you the ability to monitor a model after it's been deployed. So in answering the question, how can I monitor a model? Hopefully your guys' takeaway is that you can monitor it with Imply, because they're paying me to say this. As I mentioned earlier in my talk, I usually have a practical component to my presentation rather than just talking theoretically. I can walk you guys through basically how the practical component worked, but because of difficulty I've been having with my laptop, I can't actually show you the Python notebook and the Imply product that would do this. Before I talk through how would I actually monitor a machine learning model in production, do you guys have any questions about the theoretical components that I've talked about so far? No questions? Okay.
Well, actually, I guess I just have one. It seems like you might know more about the Apache space than I do. But is there any proposal to start up with these these open source solutions for more, I guess, cloud provider based monitoring? I guess that's not really their game, is it?
Yeah, it's not really their game. Yeah, there just really doesn't seem to be like a big push for open source in the application specific tools. Like I mentioned, general purpose tools like Elk stack, Grafana, really solid for generally monitoring an application. But in terms of specifically for ML deployment, yeah, there's just not a lot of push from the big players to do this. Cool. Okay, so let me talk you guys through how the practical component of today's presentation would have worked if my laptop was working. So I had a Python notebook that allowed me to train a model, test a model, and then I kind of pseudo deployed a model. And what I mean by that is I had this model artifact running within a Python notebook that would take in predictions from a Kafka stream and then spit out new predictions into another Kafka stream that would then get fed to Apache Druid running with an imply. And with the Apache Druid running with an imply, I was able to analyze the data about the predictions that the model was making and notice that all of a sudden there was a change in the breakdown of the types of predictions that the model was making. So to be a little bit more concrete and specific, the model that I trained was trying to predict whether or not a person was in a room based on the humidity, temperature, light, time of day, a lot of different components of the room. So when I deployed this model, pseudo deployed it in my notebook, originally it worked great. But because my training data didn't have any cloudy days in it, when there was actually a cloudy day in the real world, my model's predictions went way off kilter. And all of a sudden, it wasn't able to make good predictions anymore. And I was able to pick up on that using an alert set out by imply, and then analyze the data using Pivot, the custom data visualization framework that we've built on top of Apache Druid. And this would have let me go back and trade a new model to deploy again. Now, I promise this is much more interesting to actually look at the code and walk through how this is done than it is to hear me talk about this. If you're interested in seeing a demonstration of imply and seeing the visuals of how theoretically you would do this, feel free to reach out to me over LinkedIn or over email. I'd be happy to give you a demo once I get my laptop back in order. So yeah, that's my presentation. I really appreciate the engagement that you guys had. If you have any other questions, I am here for as long as you guys need me. Super happy to chat about monitoring machine learning models, deploying them generally any way that we can provide business value through machine learning.
I have a general question to start. I'm sure there are some people thinking about this. How would you get started if you were really interested in productionizing ML, becoming an ML engineer? Are there any other resources that you would be really interested or you think are particularly good?
Yeah, I think this CD for ML blog post from Fowler is incredible. I mean, it's so well thought out. It's so in depth, really just well formatted and structured. So I would definitely say start by reading this. And then from there, I think there's some machine learning engineering. The key word to look for is basically machine learning engineering, right? Because there's the modeling, the research, the data science component, and then there's the component of taking the machine learning model and actually deploying it. And if you're interested in that part in particular, machine learning engineer is kind of the job title that you're thinking about. And it's worth noting that although it was said that data scientist would be the sexiest job of the 21st century, as it happens, machine learning engineer has eclipsed us in terms of the amount of unfilled jobs and the amount of and the salary for those jobs on average. So it's definitely a very powerful field because companies are realizing that just paying a data scientist to make a model in a sandbox doesn't provide a lot of business value. You actually need to turn abstract concepts and models into deployed code in order to get value from them.
I have a question.
If I may ask, oh, sorry, go ahead.
Sure.
Go ahead, I'll go next.
Yeah. What sort of granularity do you monitor? So your example is you're looking at the outputs of the model. Does it ever have an advantage to actually look at what is the internal states, rather than just the outputs? And then if you are looking at internal states, where does it end? And how do you abstract to actually make an alerting system?
Sorry, by internal states, do you mean you have a continual learning algorithm that is changing over time and you're monitoring the parameters on that, or?
Not necessarily. Let's say you just have a 2-layer fully connected network. You're monitoring the output as you do it now. Is there any advantage to monitoring? Let's say the output is still fine, but you're noticing drift in the first layer.
I see what you're saying. Yeah, so I actually like would classify that as being part of the output, even though it's not like the prediction. And that's some of the cool stuff that like Superwise or Fiddler are doing, is they're like looking deeper into the model to make to generate metrics to analyze. So rather than just looking at the output, they're saying like, what's the confidence? What's the reason that's being proposed? Like, theoretically, maybe you would use Lime and you see a drift in terms of which features are actually being used to make these predictions. And if there's a significant drift in the features being used on average, that's like pretty indicative that maybe there's something different going on. So yeah, I don't know if it's useful really to do it on like the neuron level, just because if you haven't put a lot of work into explainability and interpretability, these neurons might be meaningless. But it's just another set of metrics that you can then use to generate an alert and then to start looking into like, hey, why is my model performing differently? But I would say like, ultimately, what you really care about is the performance of the model, not like what's going on inside of it. So maybe it's useful if it points to a change in the performance, but the fundamental ground truth is the predictions being made, which is the performance of the model.
Okay, so going back to metrics, you talked about I have a slightly theoretical question. It might be simple. So going back to the 3 metrics that you proposed, so I can imagine there are situations where your distribution of predictions change drastically, but I think it's almost impossible to tell whether it's because your data shifted or so your model could be still perfectly correct, but it's just operating in a different regime that you hadn't seen previously, and you shouldn't be touching your model and it's correct, or that your model is now wrong because you're in a different regime, you need to retrain it. Is there any way to distinguish between these two things?
Yeah, that's a really good question, and that's why I'm kind of careful to say like in the previous slide, I'm like, yeah, maybe you should go back and retrain your model, but at the very least, you should look at your model and understand what's happening, right? Because ultimately, the only way to know whether your model is continuing to perform at the same level that it did before is to generate some new ground truth and to understand the performance relative to that ground truth, right? And that's one of the difficult things about supervised learning, is that we start off by having this like nicely labeled data, but then when you actually deploy the model to production, you oftentimes don't have labeled data, right? Because it's actual production data. So the only thing that you can do is relabel production data and see, am I actually still getting the same performance? Like, has there been a shift in the number of people that are looking at like movie A versus movie B? Or is it that there's like an actual change in preferences occurring that I now need to like reconfigure my model to take into account? So with supervised learning in particular, which is the majority of learning that we see applied in ML, the only way to do it is to generate new training data or new testing data in order to analyze the model.
Yeah, that almost like requires like a new sort of paradigm of unit testing, right? Where your unit tests are evolving with your model and with your data. Like you can't just rely on your original unit test to know whether your model is working or not.
Yeah, that's a really great point. Yeah, nice job bringing it back to like fundamentals of software engineering, because that's exactly right. Like changes over time change how you can test your data. So I guess that's pseudo captured with this like test data here under testing. But you're right that like sometimes we need to update our test data and generate new test data.
Thank you.
I had a related question. So specifically with your example, the one that you would have walked us through if your laptop had been cooperating, you mentioned that the model...
You're giving off a lot of feedback. Could you...
Oh, that's better.
Yeah.
Okay. I'll probably just have my hands on the microphone or something. Sorry about that. So, did you hear what I said, or should I start?
I heard the first part, yeah.
Okay.
So in the like practical example that I wasn't actually able to show.
Yeah. So you said that it was giving a weird prediction because it had been trained on only sunny days, whereas now you're observing cloudy days. How in your practical example did you go about identifying that?
Yeah. So what I did in the practical example was I broke down open source publicly available data from UCI And I turned some of it into training data, some of it into test data, some of it into production data, and some of it into retest data, and modified the production data and the retest data. And what I theoretically did, this is very, very related to the question that was just asked. What I said verbally was that I hired an intern to look again in the room and to watch the video and relabel the data for the new use case in order to understand whether the model was still performing correctly or what was going on. And as it turned out, basically to like give you guys the spoiler, because I guess there's no narrative here anymore anyway. Basically, the model ended up really primarily focusing on the amount of light going into the room to predict whether or not a person would be in the room, right? Because if it's dark, it was for like a WeWork space. Because if it's dark outside, there's not going to be anybody in the room because work hours are from 9 to 5. So, most of the time it's going to be sunny then. So if all of a sudden it's really, really dark in the room because it's a cloudy day outside, the model is going to start predicting that the room is empty because it thinks that it might be nighttime. So this is where like interpretability and explainability can really come in handy in understanding why is your model making these predictions. But without those kinds of tools, the next best thing that you've got is an intern that you hire to like retest your or relabel your training data. Your testing data, I should say. Does that answer your question, David?
I think so, yeah.
I'll ask a question. Is there anything you'd do differently in a case where you couldn't monitor as much as you wished because maybe you're deploying on edge devices and you can only get information from some subset of them, or maybe for privacy reasons you can't get access to all the metrics you'd like? So is there anything you'd do differently in that situation, or would you just do the best effort with what you have?
I've never really thought about it. Yeah, I suppose like best effort with what you've got is probably the best way to do it. So you've got like edge devices, you're not able to capture all of the metrics from them that you might want. Yeah, I mean, I think ultimately like the only way to know what's going on in there is to know what's going on in there. So yeah, I think just capturing the best metrics you can get and then retraining at the necessity of doing so. But that sounds like a really challenging situation to try to do monitoring.
Mm-hmm. Thanks.
Yeah, sorry, I wish I had a better answer for you.
Can I ask another question?
No, you've run out. That's it.
Yeah, I don't want to take the whole time. So I guess I know it's hard enough to deal with supervised learning, and I guess that's what you primarily focused on. But if you think about like online learning settings, so if you start making mistakes because of your data distribution shift, then the new data that you will get will be affected as well. And then that will just it would be a bad loop that will totally mess up your system. So even like recommendation system, that could happen, right? If you keep recommending the same movies to the person, eventually maybe they'll start watching it and you would not get any more feedback. So how do you deal with these, I would say, like reinforcement learning or online learning situation? I know there is no clear answer. I don't know if anybody has figured it out, but do you have any ways of thinking about it?
Yeah, I mean, that's a really great question because it's something that people are thinking about a lot. And you're totally right that like there is no right answer, right? Because fundamentally, like you don't know, you don't have data about the underlying process. So how can you model when you don't have actual data? So one approach that I think the general categorization of approaches is you inject some amount of noise and you take some hit in performance in order to be able to better validate that this is in fact the right approach to take. So going off on a little bit of a tangent, if you guys are familiar with a problem called the Multi-Armed Bandit, which is like one of the most common simplifications of reinforcement learning, you think about the majority of ways that people deal with propose non-naive versions or non-naive approaches to or non-greedy approaches to the multi-armed bandit problem. They all inject some amount of like noise or imperfection in order to maximize the amount of new data that they have coming in, right? Like the greedy version would be to say, as soon as you have a positive result, start just like chasing down the rabbit hole with that positive result. But the majority of interesting and complex solutions like Thompson sampling, upper confidence bound, all of these different approaches to the multi-armed bandit have some way of injecting noise in order to validate that, if basically in order to not get caught in local minima, right? Because that's exactly what you're asking about. Like, what if I've managed to find a local minima, but there's some global minima of somebody's preferences that if I was able to model that global minima, I would actually generate more revenue for the business. And ultimately, the only way to get out of a local minima is to like add a little bit of noise to your ball so that it rolls out of there and into the next valley.
No, that totally makes sense. I guess it's the whole exploitation sort of trade-off. But I guess in this case, it would be even harder because you wouldn't be able to get an intern to label more test data for you. You just, you have to generate your own test data by doing what you just suggested, by adding in some exploration or noise into your system. But yeah, okay, that makes sense. Thanks.
Yeah.
Do I get a second question as well?
Sure.
Would you mind going to the slide with the diagram that had the loop back from monitoring to training? Yeah, that one. So I was wondering whether, throughout the talk, you've used the phrase "the model." And there are domains out there where it's not just one model. You've got lots of models to the point that it becomes difficult, essentially, to go back and manually see what's wrong with something and retraining it and fixing it. So I'm wondering whether any of these tools out there have mechanisms in place for triggering automatic retraining based on, alerts, monitoring rules, defined things of that sort. And I can give an example of a domain where that's the case. So think about what you're trying to do is you're trying to forecast electricity consumption in homes. And you want to do that over hundreds of thousands, millions of homes. And it turns out that if you build a model per home, as opposed to building a model to try to predict for all of them, then you can get quite significantly better performance. But then you have millions of models. And when one of them stops working well, you're not going to go as a data scientist and manually figure out what's wrong with that one and retrain it and go sort of manually through all the steps. So that's kind of the motivation for my question.
That makes a lot of sense. I think like ensemble models or situations where you have multiple models being applied to multiple problems, as you're specifically pointing out, add like another layer of difficulty. I would point out that like automatic retraining doesn't make a lot of sense, right? Because if there isn't more training data, then you're just going to retrain the same model on the same training data.
There is more training data because I'm talking time series. There is think about sensor data, right? It keeps coming. So you don't even have the problem of not having labeled data. The moment the present became the past, you have labeled data again. So
gotcha. So
at least that's not an issue.
Yeah. So I don't know of any, like, I honestly, I've like looked at the websites and have like gone to the demos of these solutions. I know for sure that the cloud providers don't have anything like that. The startups might, I'm not sure. I suspect not. I suspect that you would need to build something like that custom yourself. The reason for that being simply that like there's a lot of complexity that comes with the particular architecture that you're describing with having one model per home. So like if I was an infrastructure engineer trying to deal with this problem, I probably would not want to rely on an external vendor for this because I wouldn't believe that they they managed to come up with a general solution. I'd probably build something specific in-house. That's a really interesting topic. And I think, one interesting area that I personally am really excited about related to this is rather than like continually retraining your model, the concept of continual learning, right? This idea that like we as human beings don't get trained once and then go off into the real world, not updating our priors ever. But we as human beings actually are continuously learning throughout all of our time on this planet, to some degree for some of us and to a lesser degree for others. But machine learning models, currently, like although people are trying to take approaches to do this, don't necessarily do very well at continual learning. One of the areas that we see potential problems with this is called catastrophic forgetting, where like training a model on new data actually causes it to forget the previous data that it had effectively. So it stops performing well on things that it previously performed well on. One approach solution to this, as you pointed out, is just to like incorporate the new data into the old data and then train on all of the data together, maybe even weighting the data so that it's, like new data is more impactful in the training process than old data. But the problem is that when you've got really complicated models, and if you look at the real world, models are getting more and more complicated with more and more training time, the amount of compute actually required to do all of this retraining can get really big, right? So this is kind of tangential to what we've been talking about, but I just wanted to point out that there is a lot of work being done in the field of how do we incorporate new data without having to explicitly retrain our model every time new data is generated.
And just a quick follow-up, you're talking about the startups. Could you share the names, maybe either in the chat or afterwards in the slide, or because I didn't catch them?
Totally. So I think Chris links to some. Let's take a look. So the ones that I'm most familiar with are Super Wise, which is really cute. So monitoring, and then Fiddler Labs, which like focused originally on explainability, but like explainability and monitoring are tied together in a way that's oftentimes underestimated, and that I don't think that I personally talked about well enough throughout my conversation. But yeah, so in addition to the ones that Chris links to, I would also point out Fiddler AI.
Great, thank you.
Yeah. And if you're looking for a non-machine learning specific tool, Imply.
Hey, Danny. Thank you for the presentation. I have a question about the Imply and Druid part. Mm-hmm. How I understand it that for Druid, if I'm ingesting data directly to Druid, it kind of makes sense. But if my data is coming independently to like S3 and HDFS, like I usually go to like Presto or Athena to decouple storage from compute and just run my analysis there. Are there benefits to using Druid in that case if my data is already ingested to HDFS or S3?
Yeah, absolutely. So sorry, you guys, if this is not super interesting, but basically, there's two different broad approaches to ingesting data into Druid. There is streaming-based ingest, where we can support Kafka, Kinesis, Azure Event Hub, Google PubSub, and other streaming platforms are being added support to as well. And then we also have batch data ingest from S3, from Azure, GCS, and HDFS. And the reason that it's still valuable to get batch data in is because when we think about hot analytics, which is really what Imply prides itself in, what Apache Druid excels at, it's not just about being able to surface data in real time. It's also about being able to analyze that data instantaneously. So a company that I worked at previously actually offered Presto as a managed service. And I was really, really impressed when I started working with Presto, because I'd come from the world of Hadoop and Hive, where it would take me like minutes or even hours to get back a simple SQL question on big data. And I thought that's just what the world was. And then I got to Presto and I was like, wow, this is awesome. This like takes 5 to 10 seconds to get me a result. That's really cool. But then when I came to Druid, it was like, oh my God, like these results are coming faster than I can type out a SQL query. So like Matt was talking about his experience with moving to Tableau, my experience with moving to this data visualization platform that we built on top of Druid called Pivot was like, oh my God, this is super intuitive. I can slice and dice. I can do group bys. I can like interact with my data super quickly on millions and millions of records in real time without having not real time just in the sense of real time streaming, but in real time in the sense of like having a conversation with my data, being able to ask it questions instantaneously without having to write out any SQL. So long story short, I mean, I think the data lakehouse approach is pretty compelling for a lot of use cases. I don't know that Snowflake is going to stick around for super long if Starburst and Dremio do a really good job of like positioning the data lakehouse as an alternative to the data warehouse. But ultimately, I think the value that they offer is still in terms of cold analytics, like generating reports or giving you back your responses in the order of minutes, versus when you're trying to power a data-driven application, when you want to get performance and results back in real time. Quite simply put, like Presto or Athena or like any other managed service around this, like the data lake architecture, simply won't work. And there's like fundamental laws of physics that make this the case, right? I mean, there is a certain speed at which data can potentially be moved from an object store onto the CPU for it to actually be processed. And because Druid stores its data in memory, it's simply always going to be faster than the data lake approach of having the data sitting separately in an object store. So hopefully that answers the question to some extent of like, why is it still useful to bring data into Druid in batch instead of just using Presto or Dremio or one of the other solutions for this?
Yeah, that's very informative. Thank you, Danny. A quick follow-up is that, so if I understand, like, so it comes to latency. If I care about latency for interactive dashboarding and things like that, Druid is the solution. Something for, like daily reporting, probably Presto is fine. How is like usually the cost for operating these two systems? Like how much should I pay to get the benefit of something like Druid versus Presto? Like when should I consider that as something that, I don't know, does that make sense?
Yeah, it does. It does. I mean, like very frankly put, Presto is always going to be cheaper than Druid, right? Because they don't have any kind of scalability questions because of the separation of storage and compute. Versus with Druid, there's like, because everything is held in memory or at the worst case on disk, there is a very concrete tie between the amount of data that I have and the size of cluster that I need to run it. I would say that like ultimately no cost question exists in a vacuum, right? It's about the trade-offs. Like every engineering problem is a trade-off problem. And it's about the trade-off that you're willing to make between the performance of my application, like an interactive dashboard, and the amount of money that I'm willing to spend on it. So, like to be honest, like I actually don't compete very much with Presto when I'm out there hawking Apache Druid. What I've actually found that I spend most of my time replacing is stuff like Elasticsearch, like Postgres, MySQL, and I only really replace like Presto or data warehouses when those data warehouses or when Presto has been sold as the back end for a data-driven application, right? And like what I'm showing you can be thought of, this interactive dashboard can be thought of as a data-driven application. Other examples of data-driven applications, like specifically ones that use Druid on the back end, are like MoPub, which is what Twitter uses to publish analytics for its publishers. So you can see this interface might look really familiar if you were paying attention to the last screen. Basically, MoPub, this Twitter business unit, integrates Druid into their product in order to allow publishers to analyze their data in real time. And not only in real time, but to like have a conversation and interact iteratively with their data. So I would say if you care about your users having the experience of things seeming instantaneous, then it's worth paying for Druid. If, as you point out, like you're just running ETL or like daily reports, Presto, data warehouse, whatever, like they're all going to get the job done.
Yeah, that's a clear distinction. Thank you, Dan.
Yeah. And bringing this back to the conversation where we started with machine learning models, right? I think it's really valuable to think about stuff like real-time data coming in and the ability to really quickly interact and analyze data, right? Because when I see really rapid performance degradations, the reason that I care about getting an alert is because I want to be able to respond to things super quickly, right? There are some times when performance degradations can be okay if they happen, slowly over time, or if it's not super business critical. But if you've got a mission critical application that you need to, and your machine learning model powers that, like, let's go back to Netflix. If my machine learning model is all of a sudden failing to give any results at all, or is taking 30 seconds to give results, what does this say about how long it takes Netflix to load? What does this say about how many people are going to use Netflix that day, right? In that situation, I want to be able to respond to that in real time. I want to be able to analyze my data in real time, and I want to be able to analyze it quickly, not have to wait for my SQL query to come back. So ultimately, like, thinking about this in the application to data-driven applications, to monitoring machine learning models, like, there's a reason why people use the Elk stack and Grafana and why they would use something like Apache Druid and Imply to monitor applications in general, and specifically to monitor machine learning models, rather than using like a data warehouse.
Thanks for the question from chat.
Can you read it for me, Matt?
Yes, I will. General question: is doing online certification on data science and then doing Kaggle competitions and attending meetups enough to land me an entry job in this field?
Matt, I feel like you might be better equipped to answer this.
Okay. It depends on what your background is and if you're planning on staying within your industry. So let's say you have a master's degree in something else. You could probably get away with not just doing that, but doing that. Also, the possibility of doing a boot camp or something like that. But you will almost definitely need at least a bachelor's, most likely in a quantitative field, and then for a better chance, because essentially data science is as an industry is getting quite saturated in Vancouver. You'll probably need something along the lines of a master's or additional work as well. I'm not sure if anyone else has any other opinions about that. It's been a while.
I just add to that the additional work could be like portfolio projects. So if you're lacking in education and credentials, but you can show through portfolio that you're really talented and can do wonderful things, that helps a lot.
Yeah, absolutely. And like, make sure to get your name out there. Do presentations, maybe even lightning talk, hint. It is a really great way of getting your name out, especially in the Vancouver area. I feel like there was someone else was about to ask a question and I butted in.
Okay.
Right.
I mean, it seems like dead silence. So as promised, I'm going to go watch a Netflix movie while I eat dinner. Thank you guys so much for coming to my talk. I hope you found it valuable and found it interesting. I will share this slide deck, absolutely, as well as my LinkedIn. Please feel free to reach out and connect. If you're interested in having a conversation about Druid for powering your data-driven application, for application performance monitoring, whatever it might be, please reach out to me. Super happy to have these kinds of conversations. As you guys can tell, I'm not a very aggressive salesperson. Like, I'll just be happy to give you information, and if it's a good fit, then we can continue to explore it. Thanks again for coming. I'm looking forward to the days that I can go back to Vancouver and see you guys in person, have beer at these things, and then go skiing on the weekend.
Absolutely. We'd love to have you. Anyone who can unmute, please unmute and give Danny a round of applause, because that was really great. I'll try to get this recording up on YouTube as fast as possible. It'll probably take a couple days. But yeah, that's everything. Thank you, everyone who came out and asked all these great questions. And thanks once again to Danny.